The title of the project is Design and Development of Wind Turbine Emulator for Wind Energy Conversion System. The objective of this project, design and development of wind turbine emulator, to plot static characteristics of wind turbine emulator, to plot dynamic characteristics of wind emulator, to compare simulation result and hardware. So what is mean by exactly wind emulator? So basically in case of the wind turbine, we cannot monitor the physical parameter and the installation cost of the wind turbine is very high. So instead of the wind turbine, we can use the wind emulator. An emulator is acts like a wind turbine in a computer simulation, helping us understand how a real wind turbine would behave in a detail.
Block diagram of wind turbine emulator. Block diagram of wind turbine emulator consists of wind turbine model. Input to wind turbine model is wind velocity. According to wind velocity given to wind turbine model, it produces rotational speed and reference torque. The reference torque is given to induction motor, and the torque control system controls the torque of induction motor and actual torque of induction motor. Variable frequency drive is used to control in speed of induction motor. Induction motor is controlled to permanent magnet synchronous generator, and the generator generates electrical energy, and this energy is converted into DC form to store in the battery pack.
Mathematical modeling of wind turbine emulator. So to calculate wind turbine emulator, the actual wind turbine power is given by 1 by 2 rho, that is air density, Cp, that is power coefficient, area, and wind velocity. To calculate torque, torque is given by power upon angular velocity into radius, and the mechanical power is given by 1 upon 2 lambda rho into Cp into I cube into V square into pi. There are three parameters to calculate Cp, lambda, beta, and lambda I, and the formula for Cp is C1 into C2 upon lambda I minus C3 beta minus C4 into e raised to minus C5 upon lambda I plus C6 lambda. So this is the MATLAB simulation for our system. There are 4 inputs and 4 outputs. The first input is radius, wind velocity, beta, and lambda, and the output we get is power, torque, angular velocity, and power coefficient. This is the subsystem for our system. This is the subsystem 1, in which we are getting the values of power and torque in terms of power and torque and power coefficient. This is the subsystem to calculate the power coefficient value. This is the output simulation of power coefficient versus tip speed ratio. As power coefficient goes on increasing, the tip speed ratio goes on decreasing. This is the simulation output for output power versus angular speed. The output power increases, the angular speed also increases, as output power is directly proportional to angular speed. The next output is output torque versus angular speed. As angular speed increases, output torque also increases, and output torque is directly proportional to angular speed. This is the result table of simulated and the calculated values. This is the this is result table for pitch angle and power coefficient. The next graph is mechanical power versus rotor speed, and this is the subsystem for this. This is the subsystem 1 and subsystem 2. This is the wind turbine emulator model, and these are the hardware results of our system. Dynamic characteristic. In dynamic characteristic, wind shear and turbine shadow effect are present. In wind shear effect, wind speed varies with the altitude. Therefore, therefore different wind speeds occur. And the turbine shadow effect. In turbine shadow effect, the tower hub of the wind turbine blocks the wind flow. Therefore, it affects on the output torque. Hence, the mechanical torque is given by Tt in bracket 1 plus A1 sin omega t plus A3 sin omega tt. Next slide. This is the picture in which the effects are shown. Next slide. This is the simulation for dynamic characteristics. The radius, wind velocity beta, and angular speed is given input, and the output is a mechanical and electrical torque and mechanical and electrical power. Next slide. This is the subsystem. Next slide.
The next one is a self-excited induction generator. We can use the self-excited induction generator as well as the permanent magnet synchronous generator. Next slide. This is the simulation of the self-excited generator. Next slide. This is the stator voltage of the self-excited generator. Next slide. The future scope of the given project is to calculate the maximum power by using the MPPT program and use the various types of the generator to get the maximum efficiency.